In this video, we're going to explore how chemical structures are actually drawn commonly in textbooks or just in general in scientific journals. And these molecules are quite commonly much more intricate and more complex than the ones we've worked on. And so they use shortcuts. I call it the abbreviated molecular structure. You will commonly see these in any sort of biochemistry, biology, and they will definitely show up in your biology class next year. And I just wanted to give you a moment to be able to see what they actually look like, including the dot diagrams and so forth. So let's go ahead and get started. So what we have here is a classic sort of abbreviated chemical structure. You notice that you have these hexagons and pentagons. You've got these sort of kinky lines where it's a straight line with an angle of some sort, and then you have letters attached to it. And you'll notice to the left of that abbreviated structure, we have the chemical formula. So this chemical formula tells us we have 10 carbons, 12 hydrogens, 2 nitrogens, and 1 oxygen. So let's work a little bit backwards. Let's start with the oxygen. When you look at that abbreviated structure, it's pretty obvious that you only have 1 oxygen because you only see 1 O in that picture. Same for nitrogen. It tells you you have 2 nitrogens. Those nitrogens are clearly indicated on that picture. You see 2 N's. But now in terms of carbons and hydrogens, that gets a little tricky. And the only way you can actually determine how many carbons and hydrogens you have is by drawing the actual molecular structure. And so that's what we're going to go ahead and start doing. So there are certain tricks on how to draw these easily, and I'll go ahead and go through those, but then in the next slide I'm going to review them one more time so that you have an opportunity to take some notes. So the first strategy that I use is that wherever we see a little angle, that is where I'm going to be putting a carbon. So here's my pen. This is a little angle right here, this little corner. I see an angle over here. Every place where we have an angle, we are going to be putting a carbon. Here's an angle over here. So we've got lots of carbons. Remember, we're going to be adding 10 carbons in all of this. So let's match it to what we have. So if I were to superimpose this, every angle has a carbon, it would look like this. All right. And that's something certainly you can do if you're given a hard copy of this and just start putting the C's. Often the case is that you won't be given the hard copy, so you're going to have to draw it yourself. So I start with my carbons, and I'll be drawing a C. And you'll notice that right now I'm not adding the double bonds, okay? I'm going to just actually create the structure. And you're going to see why in a second. It just simplifies it a little bit. Okay, now the key in all of this is also double checking what you've got. So let's see if we've got one, 2, 3, 4, 5, 6 corners. That means I should have 6 carbons, and in fact I do. Okay, let me go ahead and erase that so it becomes less of a mess. All right, so now comes the next piece. We're going to be adding now from there more carbons. Okay, so I'm going to attach a carbon here. I'm going to attach a carbon here. And from this carbon and this carbon, I'm going to be attaching a nitrogen. Okay, let's just leave it like that. I'm going to then attach from this carbon right here another carbon, that's this carbon right over here, and another carbon. And it's okay that I don't have the same structure. And then I have a nitrogen. All right, on this side right over here, I have an oxygen. All right, so that is the basic structure. Now we're going to start working on the embellishments, okay? The thing that I like to do next is make sure that my nitrogens have the hydrogen attached to it. So I have one hydrogen attached right over here, so I'm going to show that. And you'll notice that I have two hydrogens attached over here. And as I said, it makes no difference where you put them, as long as you put them someplace. I also notice I have one hydrogen attached to my oxygen. All right, so let me go ahead and erase all my doodles on my abbreviated structure so it's a little bit easier to read. There we are. Okay, next what I'm going to start doing is adding the double bonds. And I have a double bond here, I have a double bond here, and I have a double bond here. I also have a double bond here. Now, one of the things that's easy to do is to place those double bonds in the wrong spot. So really always check and match, okay? So now let's do a self-check just for right now on carbons. It tells us we have 10 carbons. Let's see if in fact we do have 10 carbons. If we don't, we need to re-look at all of this. So I'll start in this corner right over here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. So I've taken care of the carbons. I got the 10 that I expected. Again, always self-check. Now we're going to move on to the last, second to last piece, and that is adding the hydrogens. Now, for any chemical other than carbon, the hydrogens are indicated. So you notice for oxygen, it tells you it has one hydrogen. And for this nitrogen on the bottom, it tells you you have one hydrogen. And then for the nitrogen on the far right, it tells you you have two hydrogens. The rest of these hydrogens are going to be attached to carbon. And they're going to be attached in such a way that you have as many hydrogens attached to carbon so that it fulfills the octet rule. Or in other words, that it gets 8 valence electrons, or we can say 4 bonds surrounding it. So let's start with this carbon right over here, okay? So that carbon over there has 2 bonds, which means at this point it has 4 valence electrons surrounding it. Remember, each dash is 2 valence electrons, but it needs to have 8. In other words, 4 dashes. So we're going to just add 2 more hydrogens. Okay, again, it makes no difference. What I do is then I give a visual around this carbon. Do I have 4 dashes? Carbon never ever has lone pairs. It will always attach to hydrogen. Well, I shouldn't say it never ever does, but it would be indicated. Here's another carbon that only has 4 valence electrons or 2 dashes. So I'm going to have to put hydrogens surrounding this. Now let's take a look at this carbon. Take a look at that carbon. Do you notice you have 1 dash here, 1 here, 1 here? This already has 4 hydrogens surrounding it. And so for that reason, we do not need to add any more. How about this carbon right over here? It has 3 dashes. 2 are the double bond. And then we've got 1 here. So we've got to add another hydrogen so that we have 8 valence electrons. And again, we're going to, at this point, ignore the nitrogens and the oxygens. We're just caring about the carbon. Let's move on to the next carbon. The carbon down here has 4 dashes or 4 bonds. That means that it has 8 valence electrons. That's the case for this one up here. The one at the very top over here only has 3 bonds, so we're going to have to add another hydrogen. This carbon has 4 bonds, or 8 valence electrons. This one only has 3. We need to add more, as well as this one. Okay? So, next piece. Let's count that, let's just double check that all of our carbons have those 4 bonds. And it looks like they do. And I always have to double check because it is very common that I make mistakes. All right, so let's count whether or not we got it right. Remember, we were saying that we should have 12 hydrogens. Let's count if we have 12 hydrogens. Let's keep our fingers crossed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wonderful. I did my hydrogens correctly. It's a great way to check your work. Now the nitrogen, remember, needs to have 8 valence electrons, but this nitrogen only has 3 bonds, which means it has 6 valence electrons. And we know that nitrogen already has a lone pair if you were to draw the dot diagram. So I'm going to show that lone pair. That's the case for this nitrogen also. Remember, nitrogen has only 3 bonding sites, which means that it has 1 lone pair. And for this oxygen right here in the corner, oxygen, if you remember, has 6 valence electrons. That means it has 2 sets of lone pairs and 2 bonding sites. So I'm going to go ahead and draw those. All right, so there is my molecular structure of what it would look like with the lone pairs. When you're going to be working through your work, you're going to notice you're going to be doing the same thing. So let's review some strategies of how to make it easier. So the first thing I would do is replace every angle with a carbon. Okay, that's something we did where I superimposed a C on top of all of those little angles or kinks with carbon. Then I would add the double bonds and add the hydrogens that are attached to elements other than carbon. So I attached the hydrogens to the nitrogen in my example, and I also attached the hydrogens to the oxygen. Okay, I want to leave the carbons for the next step. So think 8 is great. I wanted to get some sort of fun slogan there. Remember, every carbon will have as many hydrogens attached to it until it has 8 valence electrons or 4 dashes. Carbon does not have lone pairs, okay? And lastly, add the lone pairs to elements that are not carbon so that you have 8 valence electrons. So I added lone pairs on the nitrogen as well as to the oxygen. And remember, you're always wanting to get 8 valence electrons. So what happens when you're presented with this situation where you're given a molecular structure and you need to actually draw the abbreviated structure? So the first thing that you're going to do is you're going to more or less replace every one of those carbons with a kink. And if you notice, this is still serotonin. Serotonin is a chemical that your body produces that makes you relaxed and feel very good. It's in chocolate. Your gut and your brain use it, and it's kind of an uplifting, relaxing sort of chemical. And people even use it. Yeah, they use it for all sorts of things. So I'm going to replace every carbon with a kink. Okay, so you notice I have 6 carbons. So I'm going to create what looks like a hexagon. I'm going to place those double bonds where they belong. Then I'm going to, again, create a kink over here. Have this be attached to a nitrogen. The nitrogens are going to be ones that you're going to actually have to say what it is because every angle is assumed to be a carbon. Then I have a kink over here because of the carbon, another one over here, and I can add, just make sure I have enough, a nitrogen over here. For the nitrogens, I write down how many hydrogens are attached to them by just adding, there we go. And then over here I have an OH, okay? Don't forget this double bond because I just did, otherwise you're going to have issues. So I'm going to check my work. All right, so anything that where any carbon that has hydrogen attached to it, you're not going to add the hydrogens. It's only for the oxygens and the nitrogens. Any chemical other than carbon needs to show how many hydrogens are attached to it. And you also don't include lone pairs. So I'm just going to make sure one more time that I've got this drawing done correctly. It looks like I do. And now using the molecular structure, I'm going to write down my chemical formula. I always start with the carbons first. And in this case, I have 10 carbons. The hydrogens, I have 12 hydrogens. After carbon, I do the hydrogens. And then usually what I do is I go from least electronegative to most electronegative. There are so many exceptions to this rule that I really don't care how you write it as long as you write the carbon first and the hydrogen next and then work your way through. All right, so that gives us our chemical formula. Just a reminder, the ways to write chemical formulas, most of the time it's from least to most electronegative. There are exceptions. When you have something that has carbon in it, always start carbon with carbon and then follow it by hydrogen and then add the rest of them. There's no right or wrong. Well, there is no right or wrong on how to write these, but that's the most common way. So now how is it that I would use mole view to actually show this chemical formula? So I'm going to open up mole view. Let me go ahead and escape this here. All right. And get into mole view. Here we are. So remember, for mole view, you want to put things in the trash. In order to do mole view is one of those computer programs that's only as smart as you are. That means you need to draw it out on a piece of paper before you draw it out on mole view. And my suggestion is start with the most intricate structure first, okay? So right over here, I know that I have what is called a cyclohexane. Remember, for our serotonin, we had a hexagon where we had our carbons. So I'm going to click that and place that onto my sketch or my canvas on the left-hand side. So that instantly draws out my 6 carbons. Next, I want to add some double bonds. So I'm going to click my double bond first, and then I'm going to add the double bonds. There are 3 sets of them, and they seem to skip, okay? From one of those double bonds, I have, look, and I'm always looking back at my sketch here, even as I'm working on this, I have a hydrogen attached to it. An oxygen. So I'm going to click the oxygen. I'm going to hover over my carbon, click and drag. There I've got my oxygen. Don't worry about the hydrogens until afterwards. Okay, next comes the other ring that I have attached to it. And so I think the easiest way to do it is just manually put it on there. So I click my carbon, I hover over the carbon, I click and drag. There we go, I get that carbon. I'm going to do that with my other carbon. And then lastly, I'm going to go to the nitrogen. I'm going to click and drag the nitrogen. All right, and then to combine those two together, if I click and drag, it's going to give me another one of the nitrogens. I'm going to take this single bond and tie it together. There we go, and make sure you drag the whole way. So just again, double checking. Oh, I believe I did that incorrectly. So let me go ahead and head back. I think the way that this one works is that I have this carbon, this carbon attached to it. Okay, so looks a little unusual. That's fine. The 3D model will correct it. Just making certain I have 4 carbons in that ring with a nitrogen. Now for this carbon over here, I'm going to add another carbon. So let me let the computer know that. I have a carbon here. Yet another one. Again, I am using my drawing that I drew with you earlier to be able to come up with this structure. I click and drag the nitrogen. All right, so we've got the core, we've ignored the hydrogens. Now we're going to click this CH. We're going to have to click it a couple of times. There we go, and it adds all the hydrogens. But you notice it does not add the hydrogens for your oxygen. So we're going to have to add those on there. And so for this oxygen, I'm going to have to click and drag. For this nitrogen over here, remember that has also 1 hydrogen attached to it. And these here have 2 hydrogens attached to it. Like I said, makes no difference if it's kind of a weird shape in all of it, because the computer simulation will correct it. So I double check that I've got everything right. I instantly recognize I already have made a mistake because there is a double bond over here. So I go ahead and click this, create a double bond. Good. And just a reminder, this is just a reminder looking exactly like the shape that I drew with you in the earlier problem. This is serotonin. So one last double check. Don't worry about the lone pairs. I click 2D to 3D view and it draws out this beautiful chemical structure for me that I can rotate, and you can see this is what serotonin looks like, which definitely affects all of our brains. It's a pleasant chemical to have, and you want to have plenty of that to stay relaxed and happy.